In this video, I will show you how to classify a triangle that's graphed. We're going to classify as a right triangle or not, and we will also classify it as either being equilateral, isosceles, or scalene. Let's start with this fundamental concept of being able to use the Pythagorean theorem to find the length of a segment. I have taught you to turn this segment into a right triangle, and then you will do the Pythagorean theorem. So if I want to find the length of this, wait, we're not finding the length. We are finding the slope right now. So scratch what I just said. Rise over run. So this is 3, and what are these numbers? It's 4 and 5. So that's 9. So I have 3 and 9. Now, I could look at this as going down 3 and right 9. So that would make this a -3 and a +9. But just focus on the 3 and the 9 for a second. So the slope is rise over run. That's vertical over horizontal, 3 over 9. I like to just look back at it at the end and ask myself, look, if I'm going from left to right, am I going uphill or downhill? In this case, I'm going downhill. The fact that it's downhill is really what tells me that this is going to be a negative slope. So always check that. And of course, we will reduce this. So the slope is going to be -1/3. Okay? All right, so that's all they wanted. So now, we're going to find the slope of all 3 of these sides. So if I want to find the slope of AB, I'm going to make a triangle out of this and consider the rise and the run. So this vertical portion seems to be 6, okay, and the horizontal portion is 2. Okay, so that tells me that the slope is going to be 6 over 2, which is 3. All right, so this slope is 3. Glance back to see if it should really be a -3 or not. From left to right, this is going uphill. So that means it's a positive slope. So I am going to leave this a +3. Now let's talk about the slope of BC. Okay, if I make a right triangle out of that, it would be like this. I see the vertical portion is 3. The horizontal portion 5 is 8. Okay. Now I could look at this as going right 8 and down 3. That would make this +8 and -3. But ignore that for a second. Rise over run, vertical, horizontal. I know I'm going to have 3 over 8. It's just a matter of whether or not it's going to be positive or negative. I like to just look back at it and ask myself, from left to right, am I going uphill or downhill? And in this case, it's falling downhill. That's what really tells me that this is going to be a negative slope. Okay, so this slope is going to be -3 over 8. Okay, and finally the slope of CA. So I'm going to make a right triangle out of that. Okay, so here's a right triangle that has CA as the hypotenuse. So I see the vertical portion is 3, and the horizontal portion is, what was this, 10?
Yeah.
Horizontal portion is 10. Okay, so rise over run. That's going to be vertical or over horizontal, 3 over 10. But wait a minute, should this be negative or is it positive?
It's negative.
It's positive because we're rising from left to right. Okay, now we need to say whether or not this triangle is a right triangle. So look, we know that a right triangle has a 90-degree angle. Okay? So if it's a right triangle, there should be a 90-degree angle in there somewhere. So the thing is, that means if there's a 90-degree angle, that means that the two lines have to be perpendicular. Okay? So that's the key. Looking at these slopes, we should be able to tell whether or not any of these lines are perpendicular. And the reason is this. When you have perpendicular lines, okay, let me write this down. Perpendicular lines have slopes that are number one, opposite, and number two, reciprocal. Okay? So, for example, if I have the slope 3, which I do, but if one slope is 3, the reciprocal would be 1/3. All right? I'm just turning it upside down. And then also, opposite means I would change the sign. So, I don't see any slope that would be perpendicular to this one because I don't see negative 1/3. The reciprocal of 3/8 is 8/3. I don't see that. The reciprocal of 3/10 is 10/3. I don't see 10/3 anywhere. So none of these slopes are opposite and reciprocal. That means that none of these lines are perpendicular. So none of these angles could be right angles. That tells me that this is not a right triangle. They asked us to explain our choice, so here's my explanation. None of the slopes are opposite and reciprocal. Therefore, none of the segments are perpendicular. Therefore, none of the angles are 90-degree angle. Therefore, this is not a right triangle. All right, next I need to show you how to use the Pythagorean theorem to find the length of a segment. So if I turn this segment into a right triangle, where the segment is actually the hypotenuse, I see that one leg of this triangle is length 3. The horizontal leg, let's see, that's 4 and 5, so that's going to be 9. So a squared plus b squared equals c squared, where c represents the hypotenuse. So I'm thinking that 3 squared plus 9 squared is equal to c squared, the length I'm looking for. So that's going to be 9 plus 81 is equal to c squared. So that's going to be 90 is equal to c squared. And then if I want to get the actual length, I need to take the square root of both sides. So that tells me that the length of the segment is the square root of 81. Whoa. Let me use the thicker ink. So the segment length is the square root of 90. Did I say 81? I meant the square root of 90. So this is approximately, well, let's put in our calculator. Well, first of all, look. This is going to simplify down to 3 radical 10 because the square root of 90 is the square root of 9 times the square root of 10. So that's 3 radical 10. Okay, so I wanted to say that before I put it in my calculator. So that's why it says 3 radical 10. But if I hit this button, it gives me the decimal, which is about 9.49. Okay, so that's the length of the segment. So we're going to use that to help figure out if this triangle is equilateral, isosceles, or scalene. Remember that equilateral means 3 equal sides. Maybe I'll just write it vertically. Hold on. All right, equilateral means that we have 3 congruent sides. Isosceles means that we have 2 congruent sides. And scalene means that we have no congruent sides. All right, keep that in mind. So in order to classify, we're going to need to know the lengths of these sides. And we can use this technique that I just showed you. We can use right triangles and the Pythagorean theorem to find the lengths of the sides. So for example, if I want to find the length of AB, I can make this little right triangle out of it, where AB is the hypotenuse. So this leg is 2, and let's see, I have 4 and 5, so this is 9. Okay, so I'm going to say 2 squared plus 9 squared is equal to c squared. So that's going to give me 4 plus 81 is equal to c squared. So that's 85 is equal to c squared. So that means c is the square root of 85. I think I'll just jump over here and just go ahead and say AB is equal to the square root of 85. Okay, which is approximately, they say round to 1 decimal place if necessary. So the square root of 85 as a decimal is about 9.2. So approximately 9.2. Okay, so let's hang on to that information. Okay, similarly, we can find the length of BC. I think I'll change colors. So we can find the length of BC by forming a right triangle out of it. Okay, so this is 6 down here, and this is 7 right here. And of course, BC is the hypotenuse. So here goes the Pythagorean theorem. 6 squared plus 7 squared is equal to c squared. So that's going to be 36 plus 49 is equal to c squared. Okay, so that's going to be 85. It's going to be 85 again. Right, 58. Okay, so that's going to be 85 is equal to c squared. So that means that the square root of 85 is equal to c. So we just found out that the length of segment BC is the square root of 85, which we already know is approximately 9.2. So we have that information. So far we have 2 congruent sides. So we already know that it is not scalene. It's either going to be equilateral or isosceles, depending on if the third side is also square root of 85. So let's do the length of CA in purple. Okay, so let's make a right triangle that has CA as the hypotenuse. So this leg is 3, and the vertical leg is 5. All right, 3 and 5. Okay, so here we go. 3 squared plus 5 squared is equal to c squared. So that's 9 plus 25 is equal to c squared. So that's going to be 34 is equal to c squared, which means that CA is equal to the square root of 34. Okay, which is approximately 5.8. Okay, so because we have 2 sides that are congruent, but not 3, that means that this is an isosceles triangle. So I'm going to circle isosceles, okay, because we have 2 congruent sides. Whoops. So there's my explanation. The triangle is isosceles because there are exactly two congruent sides. AB is equal to BC. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.